This is SpaceTime, Series 28, Episode 152, for broadcast on the 26th of December 2025. Coming up on SpaceTime, detection of what could be the first ever super kilonova explosion. The Blue Ghost 2 spacecraft gets all shook up, and China's damaged Shenzhou 20 capsule returns safely to Earth. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have detected what may be the first ever super kilonova. It's thought this deep space event was caused by a star exploding in a supernova not once but twice. The historic double explosion, reported in the astrophysical journal Letters, may have produced both gravitational waves and electromagnetic radiation. When the most massive stars reach the end of their lives, they blow up in spectacular supernova explosions, which then seed the universe with heavy elements such as carbon and nickel. In fact, the iron in your blood and the calcium in your bones is made in stars. But another type of explosion, a kilonova, occurs when a pair of neutron stars, the super-dense cores of stars that have already gone supernova, smash together, forging even heavier elements, such as gold and uranium. Such heavy elements are among the basic building blocks of stars and planets. Now, so far, only one kilonova has been unambiguously confirmed to date, an historic event known as GW170817, which took place back in 2017. In that event, two neutron stars merged together, sending ripples through space-time in the form of gravitational waves, as well as electromagnetic radiation in the form of light waves. That cosmic blast was detected in gravitational waves by the National Science Foundation's LIGO Laser Interferometer Gravitational Wave Observatories in Louisiana and Washington State, and by its European counterpart, the Virgo Gravitational Wave Detector in Italy. And it was also detected by dozens of ground and space-based telescopes. Now, astronomers are reporting evidence of what could be a possible second kilonova event, but the case is not yet closed. In fact, this situation is much more complex because the candidate kilonova, catalogued as AT2025ULZ, is thought to have stemmed from a supernova blast that went off hours earlier, ultimately obscuring astronomers' view. The study's lead author, Manzi Kasliwal from Caltech's Palomar Observatory, says the eruption looked just like the first kilonova in 2017, at least for the first 3 days, but then it started to look more like a supernova. She says the evidence suggests that this oddball event may be a first-of-its-kind superkilonova or a kilonova spurred by a supernova. Such an event had been hypothesized, but never before seen. Evidence for the possible rarity first came on August the 18th, when the twin detectors of LIGO in Louisiana and Washington, as well as Virgo in Italy, picked up a new gravitational wave signal. Within minutes, the team that operates the detectors sent an alert to the astronomical community, letting them know that gravitational waves had been registered from what appeared to be a merger between two objects, with at least one of them being unusually small. The alert included a rough map of the source location. Astronomers are continuing to analyse the data, and it's clear that at least one of these colliding objects is less massive than a typical neutron star. A few hours later, the Zwicky Transient Facility, a survey camera at the Palomar Observatory, pinpointed a rapidly fading red object about 1.3 billion light-years away, which they then catalogued as AT2025ULZ, and which is thought to have originated at the same location as the source of the gravitational waves. About a dozen other telescopes quickly set their sights on the target to learn more. Those observations confirmed that the eruption of light had faded fast and glowed in red wavelengths, just as the GW170817 kilonova had done 8 years earlier. Now, in the case of that kilonova, the red colours came from heavy elements like gold. These atoms have more electron energy levels than lighter atoms, and so they block out more of the blue light that let red light pass through. Then, in the days after the blast, AT2025ULZ started to brighten again. It turned blue and showed signs of hydrogen in its spectra, all very suggestive of a supernova, not a kilonova. More specifically, a stripped envelope core collapse supernova. Now the thing is, supernovae from distant galaxies aren't generally expected to generate enough gravitational waves to be detectable by the LIGO and Virgo observatories, whereas kilonovae are. And this led some astronomers to conclude that AT 2025 ULZ was triggered by a typical supernova and not, in fact, related to the gravitational wave signal. Kasliwal says several clues tipped her off that something unusual was going on. Although AT 2025 ULZ didn't resemble a classic kilonova, it also did not look like an average supernova. Additionally, the LIGO-Virgo gravitational wave data had revealed that at least one of the neutron stars in this merger was less massive than our Sun, and that's a hint that one or two small neutron stars may have merged to produce a kilonova. Bit of background now. Neutron stars are the leftover remains of massive stars that explode as Type II supernovae. Stars go through their lives fusing progressively heavier and heavier elements, hydrogen to helium, helium to carbon and oxygen, and eventually all the way to iron. However, no matter how massive a star is, it can't fuse iron into heavier elements. And without the outward push of nuclear energy keeping the star in balance, it collapses inwards under its own gravity, in the process exploding with a tremendous blast called a core collapse or Type II supernova. The super-dense remnants that are left, the crushed core of the original star, is called a neutron star. They're the densest objects in the universe other than black holes. In fact, just a teaspoon of neutron star material would weigh billions of tons. Neutron stars are thought to average around 25 kilometres wide, and with masses ranging from 1.2 to around 3 times that of our Sun. Now, some theorists have proposed ways in which neutron stars could be even smaller, with even less mass than the Sun, but none of these have been observed so far. The theorists have invoked two possible scenarios to explain how a neutron star could be that small. One hypothesis involves a rapidly spinning star going supernova and then splitting into two tiny subsolar neutron stars in a process called fission. In the second scenario, known as fragmentation, the rapidly spinning star again goes supernova, but this time a disk of material forms around the collapsing star. And this lumpy disk material then coalesces into a tiny neutron star in a manner very similar to how planets form. With LIGO and Virgo having now detected at least one subsolar neutron star, it's possible, according to theories proposed by co-author Brian Metzger from Columbia University, that two newly formed neutron stars could have spiraled together, merged and erupted into a kilonova, which then sent gravitational waves ripping through the cosmos. As the kilonova churned out heavy metals, it would have initially glowed in red, as seen by Zwicky and other telescopes. And the expanding debris from this initial supernova blast would have obscured the astronomers' view of the hidden kilonova. In other words, a supernova may have given birth to twin baby neutron stars that then merged to make the kilonova. The only way theorists have come up with a birth subsolar neutron star would be during the collapse of a very rapidly spinning star. Metzger says if these forbidden stars pair up and merge by emitting gravitational waves, it's possible that such an event would be accompanied by a supernova rather than be seen as a bare kilonova. But while this theory is tantalizing and interesting to consider, the authors stress there's still not enough evidence to make any firm claims. So the only way to really test this super kilonova theory is to find more of them. This is SpaceTime. Still to come, the Blue Ghost 2 spacecraft gets all shook up, and China's damaged Shenzhou 20 capsule returns to Earth empty. All that and more still to come on SpaceTime. One of the most important tests a spacecraft goes through prior to its launch is a good shake, rattle and roll. Passing the rigours of this test helps confirm whether spacecraft will survive the violence of a rocket launch. The 8.5 minutes it takes for a spacecraft to fly from the launch pad into orbit involves brutal shaking and astonishingly loud acoustics. So, test facilities on the ground need to be able to accurately mimic those conditions in order to ensure mission hardware can survive the real ordeal. And that's where a facility like NASA's Environmental Test Laboratory at its Jet Propulsion Laboratory in Pasadena, California comes in. Dozens of spacecraft have gone there, where they're subjected to powerful jolts, extended rattling, high decibel blasts of sound, and temperatures ranging from frigid to scorching. The latest spacecraft to get this treatment are Firefly Aerospace's Blue Ghost Mission 2 vehicles, which is slated to launch to the lunar far side next year. First built back in the 1960s and then modernised over several years, the Environmental Test Laboratory has prepared every NASA spacecraft built or assembled at JPL for the rigours of space, from the Ranger spacecraft back at the dawn of the space age to the Mars Perseverance rover, which is currently on the surface of the Red Planet, and the Europa Clipper mission, which is currently on its way to the Jovian system. And that legacy is also supporting industry efforts to return to the Moon as part of NASA's Commercial Lunar Payload Services initiative and its Artemis campaign, which will bring astronauts back to the lunar surface in the next few years. In recent months, a full-scale model of Firefly's Blue Ghost Mission 2 spacecraft was put through its paces in the lab's vibration and acoustic testing facilities. Lessons learnt with this structural qualification unit will be applied to upcoming testing of the actual spacecraft that will fly to the Moon next year. JPL Environmental Test Laboratory engineer Michael William says there's a lot of knowledge gained over the years, passed down from one generation of JPL engineers to the next. And that's all brought to bear to support today's missions. The Environmental Test Laboratory team led environmental testing for Firefly's Blue Ghost Mission 1 lander back in 2024, and they were able to see the spacecraft achieve a soft moon landing in March. Firefly's next Commercial Lunar Payload Services Initiative delivery involves a dual spacecraft configuration, carrying multiple international payloads, as well as the company's own Elytra dark orbital vehicle stacked below the Blue Ghost lunar lander. Standing more than 7 meters high, the full stack is more than 3 times as tall as the Mission 1 lander. Over several months, a structural qualification model of the full stack was clamped to a shaker table inside a clean room at JPL and repeatedly rattled in 3 directions while hundreds of sensors monitored its rapid movement. Then, inside a separate acoustic testing chamber, giant horns blasted at it from openings built inside the room's 41-centimetre thick concrete walls. These horns use compressed nitrogen gas to pummel the spacecraft with up to 153 decibels of noise. That's loud enough to cause permanent hearing loss in a human. Each type of test at JPL involves several increasingly intense iterations. Between rounds, JPL's dynamics environment experts analyse the data to compare what the spacecraft experienced to computer model predictions. Sometimes a discrepancy leads to hardware modifications, and sometimes it's simply a tweak to a computer model. Of course, engineers and technicians are careful to push the hardware to its limits, but not beyond. Williams says you can either undertest or overtest, and both are bad. If you overtest, you can break the hardware. If you undertest, the hardware can end up breaking the launch vehicle. So it's a fine line. Problem is, there are some tests you simply can't do on structural qualification models. Since the model itself isn't launching to the Moon, Firefly's recent Environmental Test Laboratory visit didn't include several types of trials that are generally completed only for flight hardware. A launchpad-bound spacecraft will also undergo electromagnetic testing in order to ensure that signals from its electronics don't interfere with each other or with ground systems. And in what's probably the best-known environmental test, flight-bound hardware is baked or chilled at extreme temperatures in a thermal vacuum chamber. The multiple thermal vacuum chamber facilities at JPL include 2 large historic space simulators built within NASA's first few years of existence, one chamber that's almost 3 meters in diameter, and another that's almost 8 meters across. Still, the completion of environmental test laboratory testing on Firefly's structural qualification model helps prove the eventual operational spacecraft will survive its ride out of Earth's atmosphere aboard SpaceX's Falcon 9 rocket. Firefly's Blue Ghost 2 mission team are now turning their focus to completing the assembly and testing of the actual flight hardware for launch. Once at the Moon, the Blue Ghost lander will touch down on the far side, delivering its payloads to the lunar surface. These include Lucy Knight, a radio telescope that's part of a joint effort by NASA, the US Department of Energy, and the University of California, Berkeley. There's also a payload developed by JPL called User Terminal, which will test a compact, low-cost S-band radio communication system which could enable future far-side missions to talk with each other and to relay to orbiters. Meanwhile, Firefly's Elytra dark orbital vehicle will have deployed into lunar orbit the European Space Agency's Lunar Pathfinder communications satellite. Both Blue Ghost 2 mission vehicles will remain in orbit around the Moon, acting as relay satellites sending data from the lunar far side back to Earth. And it's all possible thanks to testing at the Environment Test Laboratory. This report from NASA TV.
The mission of NASA's Jet Propulsion Laboratory is to explore space in pursuit of scientific discoveries that benefit humanity. To fulfill this mission, tests performed at JPL's Environmental Test Laboratory ensure spacecraft can survive the rigors of launch and operate in the extreme environments of space. Every JPL spacecraft is tested in the Environmental Test Laboratory. Vibration testing simulates the mechanical vibrations experienced during launch. In order to have a successful mission, JPL spacecraft must first survive the ride to space. The reverberant chamber simulates the acoustic noises and sound waves generated from launch. Acoustic testing is particularly stressing to large surfaces, such as spacecraft bodies and antennas. Shock testing simulates the shock waves that occur during separation events from launch and throughout the mission. The tunable shock beam provides a reliable and repeatable method for simulating these highly energetic and instantaneous conditions. The spin balance machine measures mass properties for accurate guidance and control of spacecraft as they navigate through space, enter orbits around a planet, and land on the surface of Mars. Static load testing simulates the intense structural loads experienced during launch and landing. Instrumentation services are provided for all environmental testing to monitor the hardware under test and record and process the critical test data. Test method consultation is provided to all JPL flight programs to help plan and prepare for their testing needs. Thermal vacuum chambers can simulate the extreme temperatures and vacuum of space and of other planets. Whether the spacecraft is orbiting Earth, landing on Mars, or exploring the outer planets of our solar system, thermal vacuum chambers of different sizes and capabilities are available to meet all the different environments and testing needs of JPL missions. The 25-foot space simulator is the largest thermal vacuum chamber at JPL. Built in 1961, the chamber is 25 feet in diameter and over 80 feet tall. Using high-powered lamps and mirrors, the 25-foot space simulator can simulate a uniform solar beam with an intensity of up to 2 suns. From Voyager to Cassini to Perseverance and the Mars helicopter, the 25-foot space simulator provides the precise environments to test and certify JPL spacecraft for their mission. In the quest for scientific discovery under the extreme conditions of space and other planets, environmental testing is essential to every JPL mission.
This is SpaceTime. Still to come, China's damaged Shenzhou 20 spacecraft returns safely to Earth empty, and later in the science report, a new study claims profanities aren't just fun, they may actually be a secret superpower. All that and more still to come on SpaceTime. After being rejected for its planned crew return mission to Earth following damage by space debris, China's Shenzhou 20 spacecraft has undertaken a successful unmanned return to Earth, landing safe and sound in the Inner Mongolian desert. The spacecraft was slated to carry 3 Tigonauts back to Earth last month following their 6-month stay aboard Beijing's Tiangong space station. But as they were preparing their craft, the Shenzhou 20 crew spotted damage to the capsule's viewport, describing it as a triangular paint-like mark. They then proceeded to photograph the damage from multiple angles and under different lighting conditions. At the same time, cameras on the space station's robotic arm took supplemental external images. Eventually, mission managers identified the flaw as a penetrating crack. Something, most likely space debris, hit the spacecraft hard. The debris responsible is thought to have been just a millimetre or so in size, but travelling at very high speed. Ground teams then conducted simulation tests and commissioned 2 research institutes to perform their own wind tunnel testing for independent verification. The findings all suggest that in a worst-case scenario, the cracks could spread, causing the outer pane to detach, which then could lead to the failure of the inner pressure sealing glass. That would mean cabin depressurization and the ingress of high-speed superhot gases, killing the crew. Mission managers decided it was simply too dangerous to send the crew back to Earth aboard the spacecraft. Eventually, they instructed the returning crew to instead use the newly arrived Shenzhou 21 spacecraft. The Shenzhou 21 had docked just days earlier, carrying a replacement crew. Of course, it was a risky decision, because it meant the Shenzhou 21 crew were now without their own escape system in the event of an emergency aboard the space station. The good news is China had a spare capsule and rocket available. They launched the Shenzhou 22 spacecraft days later, providing a new return vehicle for the orbiting crew. And it wasn't a total loss. The Shenzhou 20 unmanned return mission has provided lots of meaningful real-world experimental data which will be applied to subsequent flights. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with a science report. There are new warnings today that dengue fever is increasing, claiming lives on Australia's doorstep, and that Australian outbreaks are often traced to travellers returning home from popular holiday spots in Asia. A report in the journal Nature Communications warns that the problem's expected to get worse, and so Australian researchers are now rolling out an early warning system to help detect outbreaks in Southeast Asian nations. Dengue fever affects some 400 million people globally each year, and it's expanding across tropical and subtropical regions. Being able to predict dengue outbreaks weeks or even months in advance will save lives. The study's authors say new computer models and early warning frontline public health teams are now being rolled out across selected regions of Vietnam's Mekong Delta. This will be one of the first large-scale early warning systems to be trialled in the real world. And it's not the only mosquito-borne disease medical authorities are worried about. There's a fresh warning today about an increased risk of catching Ross River virus as temperatures increase across Australia. A report in the Australian and New Zealand Journal of Public Health says around 3,000 cases of the mosquito-borne disease are now being reported in Australia each year. Ross River virus causes a rash, fever and joint pain, which in some cases can lead to chronic symptoms. Australian researchers have analysed 30 studies investigating the impact of temperature on Ross River virus infections, as well as on Barmah forest virus. They say higher maximum temperatures were linked to higher Ross River risk for most of coastal Australia. Although some studies found minimum temperatures appear to increase infection risk in Darwin and some inland regions of South Australia, Victoria and Queensland. But research on inland Australia remains limited. The best way to avoid infection is to keep covered when mosquitoes are about, especially at dawn and dusk. A new study claims profanities aren't just fun, they may be a secret superpower, boosting your strength and staying power. The findings, reported in the journal American Psychologist, are based on research asking 192 people to either turn the air blue or say something neutral every 2 seconds while doing push-ups. And they found that foul-mouthed participants did more push-ups for longer than the others. The authors think it may be because swearing helps you overcome inhibitions, pushing you harder in tests of strength and endurance. Debate on the benefits of drinking water fluoridation has been raised again in the United States, and that means people in Australia are also taking notice. Fluoridation's long been heralded as a public health triumph. But some US counties and even a few entire states have now switched off their fluoridation equipment. Skeptics Tim Mindham says he's sad to see such a backward step being taken.
It's such a sad situation where all these sort of established medical practices which have been proven to be highly effective are being wound back just because of some pseudoscientific claims and things. It's now fluoride. Fluoride has been around for ages. In Australia, it's been around since 1953. So that was in Tasmania, actually. And in America, it's been around 80 years or so. And it's been thoroughly proved to be effective in reducing tooth decay and that sort of thing, especially amongst the young people, and that has a major financial and health benefit down the track. And yet, nonetheless, this practice of local councils, etc., adding fluoride to the drinking water has been under assault.
What are the main arguments against it?
The major issue that excessive fluoride will actually damage your teeth. It will actually scrape away the enamel surface and things. You need a hell of a lot of fluoride in water to do that. It does have an effect, but you need a lot more fluoride than you're getting, which is basic dose is 1 milligram per litre. And the same thing with a study, and you put it in quotes, showed that supposedly kids with fluoride in their drinking water have a lowered IQ. The reports are very dodgy on various grounds. One is that it's in places where the water quality is variable. A small number of people, and even the authors said, as they always do, need more research. They can't have a firm conclusion. But the experience over 80 years shows that fluoride has a major benefit. The problem is for some local councils and some governments and things, and state governments, whether it's in the USA or in Australia, wherever, is that they're being lobbied by anti-fluoride groups, which are the same people by and large as the anti-vaccination people, with all sorts of spurious claims, allied to the fact that it does actually cost money to put the fluoride in the water where it's necessary to put it in the water. There's a lot of natural water which has high levels of fluoride. You don't need to add fluoride to the water, it's there already. So yeah, it's a very sad situation. Queensland in Australia has the lowest level of fluoridation in Australia, and it's getting worse.
And what are we finding with people in areas that do not have fluoridation?
You start off with the good side is that fluoride has been credited with massive reductions in tooth decay, and then the opposite happens when you take away the fluoride, that pretty quickly, like you're talking within a matter of about 5 years or so, the incidence of tooth decay rapidly increases. There was a thing in Ontario. They voted to stop fluoridation in 2013. They voted on it, which is unusual, not only just a council decision. Less than 6 years later, the county health agency reported that oral screenings at schools were showing that the percentage of kids with decay or requiring urgent care increased by 51%. So in other words, you've got kids needing urgent dental requirement, and those who didn't require any care decreased by 43%. The incidence of the dangers of not having fluoride are obvious. It's fairly immediate and it's clear, and yet you still have this
thing in Sydney.
It was first put in Sydney in 1968, and the fluoride rate, at least a few years ago, had a look at a map from 2017. The fluoridation rate was 93% in New South Wales, 100% around Canberra, but 76% then was up in Queensland, and it's getting lower. So in Australia, it's been going largely for 50 years or so. Right? It's proved worthwhile.
That's the Skeptic's Tim Mendham, and this is Space Time. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.